Well, great. Well, welcome everybody. Glenn Wilcock. I'm the IBM ZOS DFS MES Chief Product Owner. So I focus on strategy around storage, data resiliency, lifecycle management, things like that. And today we're going to walk through a roadmap to leverage object storage. And here's your classic ZOS environment. You got the IBM Z, you have your disk environment, you have your tape environment. And now a lot of clients are looking to leverage object storage within the environment. And I've heard all kinds of reasons why, whether it's a CXO has says thou shalt start leveraging cloud object storage, whether you got a really good deal on a lot of object storage, or there's specific value or technology within object storage that you're looking for. But there's many solutions around object storage. It's highly available. It's generally cost effective. It's hybrid, which is really attractive. So you can have private, public, multi-vendor. There's the encryption and immutability. The immutability is what a lot of people are looking for around cyber resiliency. It's scalable. And one thing that's very unique is the storage and data are shareable across platforms. So today, in your classic disk and tape environment, the ZOS data is very siloed from the rest of your environment. And so you have to have some kind of virtualization layer in order to share your ZOS data with other platforms. With object storage, it breaks that silo and it says, hey, my ZOS data that I store on object storage can be in a format that it's immediately consumable across my enterprise. And so today we're going to walk through a roadmap, all of the different options that are available today on ZOS to be able to leverage object storage within your ZOS environment. There's three primary use cases that we're going to look at and dissect. One, solutions transparent to ZOS. So these are solutions that you can just drop right in and none of your ZOS applications are even aware that your data is going to object storage. Secondly, you can leverage products that are object aware. So products today that target either disk or tape that now target object. And so once again, you don't have to update your applications because these products have been updated to leverage object storage without your applications being aware of that. And then the third way is to specifically update your applications and processes to directly access object storage. What are some of the solutions that are transparent? They're around virtualizing tape. So we have tape today. So it's adding a virtualization layer that either through the 7700 that can now target object storage for colder data. That's a 7700 cloud storage tier. Or we have some smaller shops that say, hey, I don't really leverage tape enough that I need that CapEx expense of tape. And so there's a product called IBM ZOS Cloud Tape Connector that it will virtualize the tape such that when you write to tape, it will intercept that and actually redirect it to cloud. As far as products that are object aware, we have many of them. We have OAM for unstructured data. We have DFS MES that supports the DSAK transparent cloud tiering. We have the 7700, which is the tape system, which can be a target of the disk cloud tiering. And then we also have a new product called DFS MES Cloud Data Manager that can move your data from where it resides today on virtual tape into object storage. And then lastly, in 3.1, we announced DFS MES Cloud Data Access and a new utility called GDK Util. CDA is another access method. The access methods available today enable you to target disk and tape. Cloud Data Access as an access method enables you to target cloud object storage. And then GDK Util is, think of it as an IEBGener to be able to target data to object storage. So you can see there's a lot of solutions here. I'm going to, at a high level, cover them. And then, if there's any interest in specific products, feel free to reach out to me and we can do a deep dive on many of these. One thing that I want to point out is these all work together. There's only two of these that don't work together. It's an either or, and that would be for your virtual tape. If you want your tapes to go to cloud object storage, you would select either the 7700 cloud storage tier or the cloud tape connector, not both of them. But either of these can work with all of these other solutions, and they all have their specific use cases, and that's what we'll talk about today. So why all the solutions, and why would I choose one or the over another, or be interested in one and not another? I broken it down by 4 critical things to look at. One, above all, is maintaining SLAs. Whenever you target object storage, you're now no longer going over FICON, you're going over Ethernet. It's an IP interface into your storage. So it totally changes things. You have to be aware when you start leveraging Ethernet instead of FICON, hey, can I achieve the same SLAs that I have today? Is it application transparent? In other words, do I have to make changes to my applications in order to leverage object storage? Can I leverage specific cloud capabilities like object lock, versioning, or things like that we've heard about within object storage? And then is the data shareable that I'm writing? And so for each of these, you can see that I've kind of put colors in there. As far as green is gold, you're good to go. Yellow, it's something to consider, and red is no. That doesn't apply here. And so as we walk through each of these, I will actually go into each of the colors for each of these. So a little more specifically, let's first look at the data path that we talked about of going for each of these. So for the 7700 cloud storage tier, or for the cloud tape connector, for the 7700, that's going to be a virtual tape going from your cache into object storage. And then you can see for cloud tape connector, I'm now bypassing any type of physical storage, and I'm going directly from ZOS to cloud object storage. For OEM, once again, it's direct from ZOS to cloud object storage. For transparent cloud sharing, one nice thing about that is you can see that it doesn't originate from ZOS, but rather it originates from the DS8000. It's the ability of the IBM disk frame to write data directly to either an object store within your 7700 or directly to classic cloud object storage. You can see here that there's no host involvement, which is one of the benefits. Cloud Data Manager, the new product, can migrate your existing HSM ML2 data to cloud object storage for you. And then lastly, we have DSS full volume dump for cyber resiliency. Once again, you can see here that it's leveraging cloud objects, or the transparent cloud sharing from the DS8000. And then lastly, we have Cloud Data Access, which is once again your ZOS applications writing over IP over Ethernet directly to cloud object storage. Okay. Now let's look at specifically solutions that are transparent to ZOS, which are your virtual tape environment. So as we talked about cloud storage tier, just to get into some specifics, it's transparent to applications, which is really nice. Another nice feature is it's managed by your management class policies for your 7700. So you have partitions within your 7700, and within those partitions, you can define a policy for how quickly the data moves out of cache for that specific partition. Other clusters within the grid will have access to any volumes that you've put into the cloud. And so it's just a really nice solution. One of the things that I like to point out, the best part of cloud storage tier, if you remember the last chart, it's the only one where maintaining SLAs is green. Why? Because all of your reads and writes are still out of the disk cache. It's just your older data that you're moving to object storage. And so you still get the same write speeds going to your 7700, and for data that's still cached residents in the 7700, you're still getting those same read speeds. Totally transparent to your applications. The data is not shareable. This is 7700 object store data in 7700 format. You can't share it off platform. What you can do is leverage some cloud capabilities, and that really depends. It really varies based off of what the 7700 is able to support. So anybody interested in this, it would be good to have a deep dive into this. What is the data? What data is really good for this? It's really data that's write once, read never. Because if you're familiar with the whole physical tape, remember when you take a virtual tape from the cache and you move it out of the cache, when you do a read against that data, it first has to come back into cache before you can access it. Also, any data that you have out here, for example, if you have backup data and you have 1,000 backup data sets on this virtual tape, if you access just one of those, it means it has to stage back in the entire virtual tape just to be able to read that one data set. So backup data is a great use case because in general, it's not referenced and it all expires collectively. So the data will go out to the cloud, and then it will expire out there. One of the use cases is HSM Recycle. You can say, well, if I have my backup tapes out there, HSM Recycle would drive all of that data back in order to do a recycle. If you are doing a public cloud provider, you could have a cost to do that ingest, to do a recycle. The last thing you want to do is pay your cloud object storage provider money to do a recycle because you're ingesting the data back into off the cloud. And so we've updated recycle so that now you can do it based off of cache residency. So here you can say maybe because it's cache resident, I'm going to have my typical percent valid of 40. When it's in the object storage, I can say percent valid 0, which says just don't recycle that data until all of the data on that virtual tape is invalid, and then just reclaim that virtual tape. And then I'm not ingesting any data. So obviously, if maybe you never get to 0, you could change that to 5, 10, or some lower value anyway. With the 7700, it's also really nice. They have various controllers that are available. You have your classic HDD cache, which is very large. So maybe you have a lot of your data in cache and you have a little bit of your older data that you never really reference anymore out in object storage. Maybe you have your flash cache, which is less capacity within the cache, but more object storage, or they have this new feature, which is a really small, fast cache, and you can put a large object store behind it. So you can see here the usable capacity per system within the cache. You get almost 4 petabytes on this one, 640 terabytes on the flash cache, and as little as 60 terabytes on this one. But notice the overall capacity on all of them is 500 petabytes. So it's just showing, hey, and another thing I like to point out is look at the throughput, 4.1 gigabytes per second. Okay, try achieving that for any cloud object storage. It's not going to happen. So that's why I say it's grain for your SLAs. You're going to get great dependable throughput over FICON with this. And then it's really just your colder data that the 7700 is automatically moving out to cloud for you. So what's one of the use cases? A use case when I work with clients, one of them say, well, hey, if I have a large scale recovery scenario, I'm concerned about getting that data back. But that's what's really nice about the 7700 and the ability to have different caches with different management classes. So this client, and I think many clients, you have different priorities for the data that you get back. We're going to call it priority 0, which is I need back immediately. And those are maybe your system packs, your DB2 environment, things like that. And then you have a priority 1, your applications, and then priority 2, which is the stuff that you need, but not immediately. And so with this, we say, hey, the P0 backups are always going to go to a partition where all of the data, it goes out to cloud object storage, but it is always cache resident. So you can say, I'm keeping this data in cache, and it's going to cloud object storage really just for resiliency. And then I have my P1 copies where I still have, and all of these you're going to see I have a total of 5 copies. It's just how many do I keep cache resident. For my P1, I'm going to keep 3 cache resident, and for my P2, I'm going to keep 1 cache resident. And so for my P0, whenever I do a recovery, it's always out of cache. For P1, for the most instances, it's going to be out of cache. And for my P2, if it's my most recent copy, it's going to be out of cache. But if I have to recover further out, it's going to be out of my object store. But it's all right. I'm up and running. I'm starting my applications. And so this is really the value of the 7700 solution. Next, let's go to your smaller shop. You say, hey, I don't need the speeds and feeds that I get with a real tape, hardware. And so cloud object storage is acceptable to me. In that case, we have Cloud Tape Connector, which is a zip-enabled software-only solution. As I said, it's going to intercept any of your tape IO, and it's going to do that to cloud object storage. It has full emulation of ZOS tapes. One of the nice features it has, it can also clone active tape. So we've talked to clients, they say, yeah, I have virtual tape, but I want copies of specific data, not only to be in my tape, but also in the cloud for resiliency. And Cloud Tape Connector can do that for you. You can also back up tape data to cloud, restore to either disk or tape. It has both compression and encryption, and it has just various features to look at. You'll notice in this presentation, I've uploaded the PDF that in the upper right-hand corner, I have hot links that if you want additional information, you can go out and you can follow that hot link. But here, once again, look at your SLAs. This is over Ethernet, it's over IP. Will meet the needs that you have. And once again, it's application transparent, it's not shareable. And then as we make enhancements to Cloud Tape Connector, we'll be able to leverage the various cloud capabilities like Object Lock, Glacier, and things like that. Next, let's look at products that actually utilize cloud object storage. One, which is a great one, is OAM, or your unstructured data. What's your unstructured data on ZOS? It's your PDF files, your video files, audio files, things like that. It's that data that you're writing with Content Manager on Demand, Content Manager, or whether you have customer written applications. So what makes more sense than to put your unstructured object data on ZOS directly to cloud object storage? And so OAM now has the capability to do that. We just had a very large US client, transferred all of their data from an older tape system to cloud object storage with OAM, close to 1 petabyte of data. And so it's just a really nice solution. What's really nice about OAM, if you're familiar with it, you can have a disk cache, a tape cache, and now cloud is just another tier within the OAM solution. OAM is included as a base license, so this everybody has. It's just, do you enable it or not? If we look at here, everything is going to be yellow. Maintaining your SLAs, whether it's application transparent or not, is really how you implement it. And then once again, as we're able to leverage cloud capabilities, we'll look at exploiting Glacier, Object Lock, things like that, and see if it makes sense for OAM. The shareable, whether that's green or red, really depends on how you wrote the data out there. If you write it with Content Manager on Demand, you have wrapper around your data, and so you really have to go through Content Manager on Demand to get the data. If you write it directly with a customer written application, OAM itself doesn't wrap the data. So if you invoke OAM directly through the API and maybe you put a PDF out there, that PDF is now directly consumable within your entire enterprise. And you can see the value of that now, really, where before you had to have some type of, as we talked about, virtualization to get to the ZOS data. If you write that data directly, it's storing it as is. Everybody knows a PDF format. Everyone knows video format. images, things like that, now directly consumable. You have what's a lot of clients are looking for is ZOS governance of their data. You still have governance of the data with OAM because OAM is managing that data while you're able to consume it directly across your enterprise. Another solution is, hey, backup and archive data, right? Cold data. That makes sense for object storage. And in our classic backup and archive, you're writing the data off of disk that comes through the host, and then you write it out tape. So you consume a lot of resources when you back up and archive data. So the whole purpose of transparent cloud sharing is it says, let's change that paradigm. Because the disk, the DS8000 can now write objects directly to either cloud object storage or object partition within your 7700. Now we have the host doesn't have to actually touch the data. The host through policies is just telling the DS8000 which tracks or which data sets, which volumes to move to object storage. So obviously the big value here is no CPU for the data movement. Obviously, the larger the data, the more the benefit. For HSM, it eliminates recycle. It also eliminates serial access to tape. So a lot of value here, obviously. Always want to point out, once again, you're not going to get the speeds and feeds that you get with when you're writing the virtual tape. So, you know, we have clients do a POC. What do you get in your environment over your Ethernet, and what data makes sense for that? Application transparent is really whether you use HSM or DSS to do that. HSM is application transparent. DSS, you need to update the keywords of your DSS jobs to do it. Once again, we're adding capabilities of various cloud capabilities to this. And once again, it's not shareable. We're writing it in HSM DSS format in the 7700 format. It's not consumable across your enterprise. So the first question clients ask, well, just how much CPU? For this, we did a test where, hey, let's move a 5 GB data set. When we write that to tape as ML2, that consumes 7.5 CPU seconds. For cloud, 0.02 CPU seconds. 375x reduction in CPU. And so we took some client data. This is an actual study that we did with a client, a financial client, large financial client here in the US. Each of these dots is an HSM migration from an SMF record. So we have HSM SMF records that'll tell you how much CPU we consumed and how many tracks we moved. And you can see it's very linear, which would be expected. The larger the data set, the more CPU, up to 80 CPU seconds for these very large data sets. I believe these were DB2 image copies. So your very large table spaces that they created the backup on disk, and then they migrate them to tape. With TCT, notice what I get, regardless of the size of the data set, I have 0.02 CPU seconds. And so another part of this study is that we will estimate your savings. So here to the right, you can see total CPU, and here, or left rather, total CPU, and here to the right, tracks migrated. And then the darker blue is the actual CPU that they were consuming on any given day. We have 3 days here. And then here's the estimated CPU in the middle, and then the yellowish orange is the tracks migrated. So on average here to the right, we're saying, hey, that you would get almost 90% CPU savings by leveraging transparent cloud sharing. There's a link that I have up here. Anybody can run the CPU estimator. Basically, you ingest SMF records, you do a sort on them, and then you ingest them in a spreadsheet. In the spreadsheet, it creates these charts for you. The best use case is DSS full volume dump, because all it's doing, it has very little overhead for the volume. It's mostly moving data, so it's a best case. For Mod 54, DSS takes about 9.3 CPU seconds when writing that to tape. Once again, 0.02 CPU seconds when writing that with TCT. That's a 465x reduction. And so obviously the larger the volume, the more savings. you get out here to an EAV, and that's a 99% savings, obviously. Very little CPU to do that data movement. So what are some use cases? A use case would be automatic migration, and that's where you're targeting data that makes sense to transparent cloud sharing. If you have we've all gotten very spoiled with all of the virtual tape because you can recall data very quickly. And because this is over Ethernet, it's not going to be as fast. So we always recommend look at your data, do a POC, see what kind of throughput that you're getting, and then target the data that makes sense for migrating to an object store. And you can see here, we're mixing solutions. So I have some data with cloud tiering that I'm targeting directly to a 7700 object store, new CPU. And I have other data that I'm writing classically to virtual tape and then leveraging the 7700 to tier that to object storage, all depending on what's my SLA for getting that data back into the host. Once again, application transparent, not shareable. Look at your SLAs, what data makes sense, and then as we add capabilities to leverage cloud object storage. A great use case that we have with clients that some have initiated with this is what they started with, is DB2 image copies. DB2 has the ability with image copies that you can say, I want to leverage flash copy. Flash copy, disk to disk. None of the data comes through the host. And now clients will generally migrate those off to virtual tape with HSM. Well, now with transparent cloud sharing, look, I now can move that data to my 7700 object tier. None of the data pass through the host. So now I get point in time DB2 image copies on both disk and my 7700. None of the data went through the host. A couple things that I want to point out for the clients to do this, you just need to point out or note that DSS doesn't know when a image copy has been migrated. And so you first have to do a recall, an HSM recall back to disk for HSM to be able to do that restore. Another thing I want to point out is this is not limited to DB2. There's nothing special here about DB2. So you can do this for if you're initiating DSS flash copy to a storage group and then have HSM migrate that storage group to object storage. Then you can also leverage multiple targets. You can go to 7700 maybe for your dailies, and maybe for your weekly, you go to your classic off-prem object store for a deep archive, a golden copy, your 7-year retention, anything like that. And then it gets even better as we look at maybe you're in a Metro Global Mirror environment. It's the storage that's doing all the replication. You have your DB2 at your Metro mirror, at your global mirror. The copies, we're using command replication to get the copy of both your primary and your secondary. When we write that to the object store, the 7700 replication replicates that across your grid. And so now you have these point-in-time copies, disk, virtual tape 7700 across your entire environment, and none of the data went through the host. You can also leverage cloud object storage there. So now it's just your cloud provider. Do you have multiple instances? Does it do the replication regardless? You can access that data anywhere. Obviously, the closer that data is to your system, the faster that's going to be. But even if it's not close, you can access it because we're just using IP. So it can be anywhere in the world, and we can access that data for you. Let's go back to the case where we talked about the 7700 and the 7700 tier. And I kind of talked about this, but this is a use case with migration. If you leverage the migration tiering with your HSM migration copies, this is what it's going to look like. You're going to have some colder data on your virtual tapes and cache. And then, as we said, if you have even one data set on a virtual tape that gets recalled, well, now I have to ingest that whole virtual tape back into my 7700. So for backup, it's a great. For migration, we have clients, you're not necessarily going to want to leverage that. So how do I get the best of both worlds? How do I keep my active data in the 7700 cache and my colder migration data in Cloud Object Storage? And that's why we created Cloud Data Manager, new product within DFSMS, and it does just that. So we can see here, maybe this data set or this virtual tape is, we'll say, 3 months old, and it has a lot of active data. We'll say that's active, but it has some cold data on it. What Cloud Data Manager says is, by policy or by criteria, you can say, take my colder data off my virtual tapes, recall it to the DS8000, and then leverage TCT to move those colder data sets either to real object storage or to the 7700 Cloud Object Store. What's the value of that? One, we maintain the original last reference date, and we maintain the original migration date. So what's one use case is, hey, maybe I want to keep a year's worth of my migration data in the 7700. If it's older than a year and I haven't recalled it, I want to go that more to maybe an archive, a deep archive. And so CDM can do that. You can say, hey, CDM, select data that's older than a year that's never been referenced, and it will do this process for that data. And now you have this very cold data is now out in object storage. And remember, we don't do recycle processing again on that. HSM will never touch that data again until you have to do a recall. And because it's still in the HSM inventory as a migration copy, just like any other, if you do a recall, we'll immediately pull it back. So nothing special that you have to do. And so we're getting, interest in this, for that use case is, hey, so now you do have the best of both worlds. I have my warm data within the 7700 for my recalls, whether that's month end, quarter end, year end processing is still in cache, but then as it gets older, we actually pull it out and put it in the Cloud Object Storage. I talk to clients, they have HSM migration data that's 30, 40 years old, never touched. Perfect use case as you pick the criteria, and then we move that data for you. And then this is just showing for your backup data, how you can leverage the 7700 cloud storage tier. So for backup data, hey, I keep so many copies in the disk cache, and then the 7700 migrates that to a 7700 bucket, where now I have my colder virtual tapes out there. And this is just one example of how the solutions work together. For my HSM migration data, makes more sense to leverage this way. For my backup data, makes great sense to leverage this. And they both, whether it's HSM or the 7700, are getting that data out to my object storage. Just a quick overview of Cloud Data Manager is it'll read the entire HSM migration control data set to give you a view of your data and what data, how much really cool data you have in there, how much data that you have. And then you can do a simulate. You can say, hey, if I select data, for example, maybe older than 2 years, how much data am I going to move? And then obviously it will do the actual migration for you. And here's just an example. This is just a screenshot of what it looks like. So this is saying, hey, select ML2 volumes that are less than or equal to 20% full. Don't process more than 500 volumes, and don't process more than 10,000 data sets. Or here in this other selection criteria, this is where a selected data set migrated to ML2 before. So this is where you can say, hey, select migration data that's older than 2 years and things like that. Next, so that's migration. Let's jump to the next use case, which is full volume dump. Very similar pictures over here. You're just doing it with at a full volume dump level instead of a DS set or at a data set level. So this is showing the same thing. If you do a flash copy to a target volume, none of the data goes to the host, and now you migrate those full volume dumps either to the 7700 object store or to Cloud Object Storage. Once again, now you have those backup copies at a full volume dump level with none of the data going through the host. Over here, obviously, here you're moving a lot of data. So this is even more, hey, what kind of SLA do I need to achieve? If you're a really large environment, odds are this is not going to be fast enough for you. And so that's where you would want to, hey, let me send my full volume dumps to the 7700. And then as they age, send them the cloud object storage. But if you're a smaller shop where, hey, yeah, this does work for me, then it's a great solution. Once again, if you do it with DSS, you have to update your DSS jobs. With HSM, it's transparent. Let's go to a use case. Maybe I need to keep a golden copy of my data. So once a week, I want to create an off-prem copy of my data. So this is a great way of doing it, what we just talked about. If you do a flash copy with no copy, space efficient volumes, that means this is consuming very little storage for that flash copy target. And then you can do an HSM, migrate that off to Cloud Object Storage, or you can dump data directly to Cloud Object Storage. You can do either one. But the data is encrypted before it goes on the line. And then, once it's in Cloud Object Storage, it's isolated, it's immutable, and it can be a way of getting a very low cost golden copy of your data out in Cloud Object Storage. One last solution that I want to talk about for TCT is DB2 system level backup. The solution was actually available in the early 2000s. And that's where DB2 and HSM work together to create a system level backup. That says, if I have an incident where I need to recover an entire DB2 subsystem, that's going to take a long time if you have to do that from all of your image copies. And so DB2 system level backup says, I'm going to create a point-in-time copy of my entire subsystem, and I'm going to create that on disk, and I can do an immediate recovery from disk, or I'm going to offload that to tape, and now I can do that to cloud. And so here, you have HSM initiating for DB2 subsystem a flash copy, and now with transparent cloud sharing, we can move that to either the 7700 object store or to classic cloud object storage. Okay, so it's the same type of concept, just at a larger level. And then once again, you can see here, hey, all of the replication is occurring within your disk or your 7700 environment. And when you need to do a recovery, the value of the 7700 is because it's replicated, it's always a local recovery. And so, recovery you want to be as fast as possible. And so it'll do a local recovery there. So really nice solution. Now let's jump to, hey, I want to actually update my applications themselves to be object aware. As I said, in 3.1, and it's actually available in 2.5 also, we came out with this new access method called CDA, Cloud Data Access. And the strategy is really, as I said before, I want, instead of my ZOS data being siloed, I want to store it in a way that I can immediately consume it across Sysplexes or across my entire enterprise. We've talked to other clients who have, Sysplexes where you want to share your data, or a bunch of monoplexes, a bunch of standalone LPARs. How do you share data between multiple, LPARs today? You have to send the data there. There is a way, but this is a simpler way to have a single shareable reference or storage media for all of your LPARs, all of your Sysplexes to share data. And so that's one of the use cases that clients are looking at. What's nice about this is obviously here, the data is shareable, and the whole point, leverage cloud capabilities. So we're looking at making it simpler. You can leverage Object Lock today, but we're going to make it simpler to leverage object lock. And I should probably explain what object lock is. Object lock basically says the cloud provider, you put a policy that says, hey, this data cannot be deleted for 90 days. Then that means nobody can delete that native data for 90 days, regardless of who you are. And so, that's when you talk about cyber resiliency, and you need to keep a copy that's immutable, it can't be changed, and it can't be deleted. Object storage is a nice solution for that. Obviously, it's not application transparent. You're going in and you're updating an application for this. And then as far as SLAs, once again, do a POC. What kind of throughput do you get in your particular environment, and does it meet your needs? Cloud data access is, you can say, well, we have the fundamentals to do that today prior to 3.1, but in 3.1, what we wanted is really an easy button. Because if you look at leveraging object storage, every provider has their tweak. Excuse me, where the authentication is a little bit different, their commands are a little bit different. And so it's, as an application owner, well, I have to go in and which provider am I using, or I'm using multiple providers. Well, they all have their tweak, and it's kind of just challenging. And doing the authentication can be challenging. And so what's an access method? The whole purpose of an access method is to make something simpler. And so that's the whole point of cloud data access, is to make that simpler. We call it the easy button. So you write to a single API, set of APIs, and then it does the translation to you based off of the authentication or the APIs for each of these providers. Okay, to make it much simpler for your application owners and to be able to go leverage this. We already have ISVs that have started to leverage it, and that's what predominantly what they tell us. Wow, thank you. It made it easier for me to provide an application. The one interesting at the last share, a vendor shared how they leverage this technology to create, air quote, a ZOS data set in the cloud. So, and that was one of our intents, is, hey, let's enable our vendors to be able to create solutions within their products to be able to leverage cloud object storage. So it's really exciting to see this. There's a lot of excitement out there around, hey, how can I leverage object storage directly from my ZOS environment? And you say, well, I don't really want to, when I want to try using this, I don't want to necessarily have to write a program or an application to do that. So as I said earlier, at the beginning, we provided a utility called GDK-util. GDK-util, think of it as an IEBgener. So instead of sending your sequential data to disk or tape, it allows you to send your sequential data to object storage, whether that's US Unix files, PDS, PDSE members, GDG versions. It's an alternative to an FTP or an ETL, or maybe using NAS storage. All of those use cases that I just talked about are what clients have come in and said, I want to stop using FTP. I want to stop using NAS storage. I want to leverage object storage directly. And they're looking at these solutions. Here's just an example of what the JCL looks like for GDK-util, where this is saying, hey, upload and convert. So one of the functions it provides is it does that translation from EBCDIC to UTF-8. So it's saying upload this text file or this text file into this particular object, and then vice versa. You can download that. And once again, you can do a convert from UTF-8 to EBCDIC. So this is a great, everything here is base ZOS, no charge, you don't have the licensing. So it's a great, hey, just go out and use it. And then I believe here, yeah, I have all kinds of links. So we've talked about a lot of solutions. If you want more information on any of them, these are in the PDF. They're all hot links. For example, cloud data access. and GDK util. For Cloud Data Access, we have a really nice content solution webpage that gives you a very nice walkthrough. And also for GDK util, which is, hey, go start experimenting today. You know, you got some extra time because, hey, let me see what this can do and what I can introduce into my environment. That TCT CPU savings estimator, you can see here, I also have a hot link here. If you're interested in our new product, Cloud Data Manager, you know, there's the hot link there. So, and that's basically everything that I wanted to cover today. Feel free to reach out, as I said, for a deeper dive into any of these, and we'll bring in the subject matter expert. So thank you. Appreciate this opportunity that we had.
Thank you, Glenn. I really enjoyed that. Good presentation.
Thanks, Brett.
Okay then, so I don't see any questions on the chat. So I'll end the call for all and maybe see you in November in our Whittleby Hall.
Yeah, there you go. That'd be great.
Very good indeed.
All right,
Okay.
thanks, Brett. Have a good one.
Thank you very much. Bye-bye.
Bye.